Welcome back, students. So in the last session, we were dealing with Newton's second law of motion, and we have also derived a mathematical formula for the Newton's second law, that was F is equal to ma. And now today, using that equation, we are going to define what is one unit of force. What is one unit of force, or what is 1 Newton? We all know that the SI unit of force is Newton. SI unit of force is Newton. Now using the equation F is equal to ma, that is Newton's second law, we are going to define 1 Newton or 1 unit of force. Let us see. We know that F is equal to ma. Now we need to define what is 1 Newton or what is 1 unit of force. Now if mass is 1 kilogram and acceleration is 1 meter per second square, then F is equal to ma can be written as F is equal to, instead of mass m we can substitute 1 kilogram. So 1 kilogram into A is 1 meter per second square. So into 1 meter per second square, that is F is equal to 1 into 1, it is 1 kilogram meter per second square or 1 Newton. So SI unit of force is either Newton or you can go for kilogram meter per second square too. So we are defining what is 1 Newton or what is 1 kilogram meter per second square. Okay. So here 1 Newton force is the amount of force needed to produce 1 meter per second square acceleration in an object of mass 1 kilogram. So 1 Newton is the force that produces an acceleration of 1 meter per second square in an object of mass 1 kilogram. This is how you define 1 unit of force or 1 Newton. And the SI unit of force is either you can go for the unit Newton or kilogram meter per second square. Hope this much is clear for everyone. Now let us see how we can derive the first Newton's law of motion using the second law. So you need to derive, we are going to derive Newton's first law using his second law. That is, we know that Newton's second law is F is equal to, the mathematical formula for Newton's second law is F is equal to ma. We have A is equal to, acceleration A is equal to V minus U by T. We have already studied in the first chapter motion, acceleration is change in velocity by time. That is A is equal to V minus U by T. Substituting it in the equation of F, we get F is equal to m into A is V minus U by T. Okay, Newton's second law is F is equal to ma. In the first chapter, we have learned an equation for acceleration A is equal to V minus U by T. Substitute this equation of A in the equation F is equal to ma. Instead of A, substitute V minus U by T. So, you will get the equation as F is equal to m into V minus U by T. Now, so we got the equation as another form of Newton's second law is F is equal to m into V minus U by T. Another form of Newton's second law is F is equal to m into V minus U by T. Now take this T to the other side of the equation. So on the right hand side, T was in the denominator part. So when it moves to left hand side, it becomes into t. F into t is m into v minus u. This t is already taken to the left hand side. Now take this m to the left hand side. On the right hand side is m into. So when it moves it to left hand side, it becomes divided by m is equal to remaining it is v minus u. Suppose if F, the force applied is 0 Newton. If force applied is 0 Newton, if the force applied is 0 Newton, then Ft by m, this whole LHS part become 0. Since F is 0, 0 into T by m will become 0. So LHS part has become 0. So the equation become, this is equation number 1 suppose. So equation number 1 becomes LHS part is 0 since F is equal to 0 Newton. So 0 is equal to V minus U. Now take this minus U to the other side, to the left hand side. When minus U move from right hand side to left hand side, it become positive U. That is, we got U is equal to V. That is, initial velocity and final velocity is the same when force applied is 0 Newton. This is Newton's first law. The object will continue to move with same velocity throughout if the external force applied is 0. That is, the object will continue to move in uniform motion. Uniform motion means throughout the motion, the object will be having same velocity. Here we have proved initial and final velocities are the same, which means the object is moving with same velocity throughout. That means the object is in uniform motion when the force applied is 0 Newton. So when external force applied is 0 Newton, the object will move in uniform motion. This is Newton's first law. So we started with Newton's second law, and when we substitute the external force as 0 Newton, we got that the initial and final velocities are the same, and this itself is Newton's first law. So we have derived Newton's first law using the equation F is equal to ma, which is Newton's second law of motion. Hope the derivation is clear. Now let us pass on to certain applications of Newton's second law. The first application is in the game cricket. When a fielder catches a ball, he moves his hands backward. When a fielder catches the ball, he is moving his hand backwards. He is moving his hands backwards and he catches the ball. Why? On doing so, he is increasing the time of catch. He is increasing the time of catch. And what advantage is there if he increases the time interval between the catch? Let us see. According to Newton's second law, we have F is equal to m into v minus u by t. F is equal to m into v minus u by t. Here, when the ball is moving through the air, the ball is having greater velocity. And we know that momentum is equal to mass into velocity. So when the ball is moving through the air, the ball is having greater velocity, which means if it is having greater velocity, it will be also having, if velocity is more, momentum also will be more. According to the equation, momentum is equal to mass into velocity. So when the ball is moving through the air, The ball is having greater velocity, which means it is having greater momentum. So, when the fielder catches the ball, the velocity of the ball reduces to 0. That means momentum also will get reduced to 0. When velocity gets reduced to 0, momentum also gets reduced to 0 because P is equal to M into V. So, if V is 0, momentum also becomes 0. So, initially when the ball was travelling through the air, the ball was having greater velocity and greater momentum. When he catches it, the velocity of the ball will get reduced to 0, which means momentum also gets reduced to 0. Now move on to this equation. F is equal to m into v minus u by t. He is moving his hand backwards, which means he is increasing the time of catch. He is increasing the time between the catch. If time between the catch increases, according to this equation, the force gets decreased. If time between the catch increases, the force gets decreased. So, if he increases the time interval between the catch, he only need to apply a small force on the ball to catch it. If he applies a small force on the ball also applies a reaction force on him. So, since the force applied by him is small, the reaction force applied by the ball on his hand will be also small. Or in other words, we can say that the momentum gets reduced to 0 taking a long time interval. So, he only need to, since momentum is reduced to 0, he only need to apply a small force to catch it. In turn, the ball will also apply a small reaction force on him. Since the reaction force is small, his hands won't get hurt. Suppose if he tries to catch the ball suddenly, the momentum gets reduced to 0 suddenly, which means he has to apply a larger force to catch the ball. If he applies a larger force on the ball also will apply a larger reaction force on his hands. So, there is a probability for getting hurt. So, in order to avoid that, he increases the time interval. So, the force applied by him on the ball gets reduced. So, the reaction force by the ball on his hand will also get reduced. So, he may not get hurt. That is why he moves his hands backward while catching a ball. Now, the second example is a karate player breaks a pile of tiles in a single blow by moving his hand faster. So, he is moving his hand faster. Again, using the equation F is equal to m into v minus u by t, we can explain this case. So, he is moving his hand faster, means the time of contact was increased because he moved his hand faster. So, he is doing in a short time interval. He is doing that action in a short time interval. So, time has short time interval, He is moving his hands in a short time interval. So, he has decreased his time of contact. He has decreased his time of contact because he does the action in a short time interval because he moves his hands faster. So, he only takes a short span of time. So, he has decreased time. When time decreases, according to this equation, when time decreases, force on it will increase. When time interval decreases, force applied will increase. So, since he is applying a larger force during a short span of time, the pile of tile gets break within with a single blow. So by moving his hand very fast, he is decreasing the time, and in turn the force gets decreased, and this larger force will allow him to break the pile of tiles with a single blow. Now next application is in a high jump athletic events. The athletes are made to fall either on a cushioned bed or on a sand bed. Why? Again, you people will be acquainted to answer this question. Just like the previous cases, the athletes are made to fall either on a cushioned bed or on a sand bed. That means the time of landing increases, because when he lands onto a sand bed, his leg will be pierced into the sand. That means the time of landing will get increased. So the force will get decreased using the equation F is equal to m into v minus u by t. We can say that when time of landing increases, force will get decreased. So he only need to apply less force onto the sand to land safely. So in turn, the sand will also apply a reaction force on him. Since the force applied by him onto the sand is less, the reaction force applied by the sand on his leg will be also less. So the impact force on him is less, so he won't get hurt. Okay, that is the reason why in high jump athletic events, the athletes are made to fall on a cushioned bed or onto a sand bed. It is to decrease the time of landing, it is to increase the time of landing, which decreases the force. Hence the impact force also will be reduced, so he won't get hurt. Okay, same reasoning as the first example of cricketer. Now next example is during a car accident, the car stops suddenly. The seat belt worn by passengers of the car prevent them from falling forward suddenly. Why do we wear seat belts while we travel in a car? This example was already discussed when we dealt with the applications of inertia. Now let us see what is the relationship of this example with Newton's second law. Again, if the car during a car accident, when the car stops suddenly, what the seat belt will do is, the seat belt will increase the time of collision, because since we are wearing a seat belt, it increases the time of motion. It increases the time of forward motion. So it increases the time of forward. When we met with an accident, the car will suddenly get stopped, and due to inertia, we will move forward. When a car is met with an accident, the car will get suddenly stopped, and due to inertia of motion, we will be moving forward. The seat belt will increase the time of forward motion. When time increases, force will get reduced using the equation F is equal to m into v minus u by t. When time increases, force gets reduced. So we are only applying a small force onto the front panel of the car. So the reaction force applied by the front panel on us will be also less. So since the reaction force is less on us, the impact force, that is the impact created by it, will be also less. So we won't get much hurt. Okay. So the time of forward motion increases, which decreases the force applied by us on the front panel of the car, which in turn reduces the reaction force, so we may not get hurt. Okay. Now the next example is of the shock absorbers. You have seen the bikes and the cycles have shock absorbers. Shock absorbers. What is the use of this? Shock absorbers. Again, when the bike or the cycle travels through an uneven road, jerks will be caused. So what this shock absorbers will do is, it increases the time of movement. It increases the time of movement, which decreases the force. When time increases, force will get decreased according to the equation F is equal to m into v minus u by t. So the force gets decreased. That means the reaction force on us will be also less. So we won't feel much hurt. Even if we are traveling, we won't feel much, we will feel less uncomfortability even if we are traveling in uneven roads. That is the use of shock absorbers. It will increase the time of motion, which reduces the force. So the reaction force is less on us, we won't feel much uncomfortability even if we are traveling through uneven roads. So that is the use of shock absorbers. Again, the next example is china and glasswares are wrapped in paper and straw before packing to avoid breakage when transported. Same reasoning. During transportation, there is a probability of collision between the products and the packages. So there is a probability of getting break. So in order to avoid that, the products will be wrapped in paper or straws. What does this do is, these materials are soft. So it increases the time. When it collides, it increases the time of collision. When it increases the time of collision, the force will get reduced. The force with which the product collide with the package will be less. So the reaction force given by the package will be also less. The reaction force given by the package will be also less. So the product won't break easily. Okay. So since it is wrapped in straw or paper, since they are soft materials, during transportation, if some collision occurs to these materials, these soft materials will increases the time of collision, which decreases the force, which in turn decreases the force, So the reaction force applied by the package onto the product will be also less. Since the force applied by the product onto the package is less, the reaction force will be also less. So there is the product won't get easily broken up. That is why we wrap paper or we wrap the products in paper or straw materials before we transport it. So these are some applications of Newton's second law. Hope it is clear for everyone. Thank you.